I'm Heath Borders. I'm the mobile technical lead at Jive Software, and I'm at Heath Borders on Twitter. This is Make Your Apps Accessible to All. So in this talk, we're going to have actually two talks in one. We're going to discuss simple Android accessibility, and we're going to address simple and complex iPhone accessibility. We're also going to talk about how to build what's called third-party accessibility services for Android. Those are super cool. So on the iPhone, accessibility falls under the UIAccessibility series of functions. That's in UIAccessibility.h. It's an informal protocol and basically builds a separate DOM hierarchy for your UI view DOM that is accessible to screen readers. And so essentially the screen reader introspects your DOM and presents that to the user. Usually, for our cases and what we're dealing with most of this talk, is we're going to be dealing with audio feedback for visually impaired users. So as you can see, it's going to break down this simple UI into a series of accessibility elements for buttons, static text, and those are the trait names. We're going to get into that a little bit. UI accessibility was introduced in iOS 3. This was actually like a major groundbreaking event for mobile OSs that had no hard keyboards. So this is actually, iOS has turned into one of the best OSs for users that need accessibility technologies, despite the fact that it has basically no hard buttons. There's been new APIs with every major release. Most of what we're going to deal with was introduced in iOS 5. So as I said, what your accessibility elements actually do are defined by UI accessibility traits. And so that is basically a large bit mask that defines, I think, 17 different things that individual accessibility elements can do. So for the most part, for simple user interfaces, you're really only going to be dealing with accessibility trait button, accessibility trait static text. Static text is what a label turns into. And so if you have things that aren't labels, like if you're using core text to draw and render custom text, then you would want to declare your accessibility element to be a type of static text. There's lots more. You can go into the UI accessibility traits headers in Xcode and review them. What's very nice about UI accessibility on the iPhone is that it provides really sensible defaults. So when you're coding up your user interface or you're building it in Xcode, you can get a lot of UI accessibility functionality for free. So basically, any UI control. So again, just a quick refresher in UIKit, there are UI views, which are that's the superclass of all types all types that are added into the UI view or the UI view DOM hierarchy. Directly under that is the UI control subclass, and all UI controls are automatically accessibility elements by default, and they get very nice accessibility traits, and they are very easily introspected by the screen reader. It's really easy that you just get all that stuff for free, and a user can explore them very easily. If you have things like a UI label or a UI image view that are not UI controls, it's really easy to turn them into accessibility elements. And basically all you have to do is just set isAccessibility element to yes. So the reason you would want to do this is that then the UI label or UI image view becomes a navigable part of your hierarchy. So if your label is an important piece of content, if you've got a big label on your page and you want the user to be able to navigate to it and read it, then you want to make it accessible so that they can touch the element with the screen reader. And what's also very nice is that UI image view provides a very nice default based on the file name of the UI image that you used. So I don't necessarily recommend doing this as your accessibility strategy, but what is nice about it is that it's just that much easier. You can literally just set isAccessibility element to yes, and you at least get something. And as we're going to see in Android, that's better than what Android provides. At least the user can make some kind of determination, even if it's not the best scenario. Now, under normal usage, basically you're only going to ever override a maximum of 4 things, but really you're probably only going to ever override is accessibility element and accessibility label. So this is what it looks like in Xcode. It's part of the attributes tab, and there's just an accessibility section. And essentially, you're just going to set is accessibility element. You'll just check the enabled button, and boom, you have an accessibility element in your UI. The accessibility label is supposed to be a one-word, or ideally one-word, very short description of the accessibility element. The screen reader is going to read this to the user as they navigate the page. Potentially, it could read all of, depending on the abilities of the user, it might read the entire UI from top to bottom. So you don't want to make the user have to wait while you enumerate a 10-word description of what your button does. That's what the accessibility hint is for. The accessibility hint describes the actual purpose of the element in greater detail. So for, and we'll get into an example of that, but like for a music app, you might have a play label, and then you'd have the hint could be starts playing the music. And the value then is if it's a stateful element, so if it's a button, you can say, well, it's selected, it's not, or you can get into more complex use cases. And of course, then you can add many, many more traits. These are, again, some of the other traits you can drop in place. So as a concrete example of this is from the Maps app, and these are the real values the Maps app uses. So for the tracking button down here, you've got the label is tracking, and the hint is activate to change tracking options. That hint doesn't change because the button is still it still performs the same action. But then as you activate the button, it cycles through its different values, and so you can continuously introspect the button and get what values it has, and it'll go between off, on, and on with heading, of course. So VoiceOver is the name of the screen reader that's used. Actually, I believe it's the name of the screen reader in OS X as well, but it is the one and only screen reader for iOS. It's baked into the system. You can get to it via settings, general accessibility, VoiceOver. I highly recommend that at a minimum you just turn this on and play around with it and see what kind of experience your user is going to have. It's actually if you're not used to it, it can be kind of annoying, but it's actually not that hard to use, and it doesn't take very long to get pretty good at working with it. And you could really do a whole talk on just how to properly interact with VoiceOver. The really essential thing for developers is to set up an accessibility shortcut. So within the VoiceOver options, there's the setup accessibility shortcut option, and you can do a number of different things. You can turn on zooming, you can turn on lots of other different options, but I recommend just enabling and disabling VoiceOver with it. And with that, then you can easily, in the middle of your testing, triple-click home and navigate through the app and make sure that it's behaving as expected. And this link right here, Apple has a fondness for ridiculously long links into their documentation. This actually goes through great detail of all the different gestures that are available. And the slides are going to be public, and I've also got a big list of links at the end of the page. So don't worry about trying to write this down, because it's hopeless. But you'll be able then to discover there's a lot of different gestures for obviously navigating forward, backward, going through individual characters of individual labels, things like that. It's pretty impressive what you can do with VoiceOver. Unfortunately, on the iOS simulator, you've really got no access to VoiceOver at all. What you do have is the accessibility inspector. And so the accessibility inspector is there just to provide you access to the values that you set on your accessibility elements. So you can kind of think of this as like spot-based mock testing for VoiceOver. So you can know that the values that you expect to be on your control are actually validated. So that's helpful if you have dynamically generated labels, values, hints, whatever. Most helpfully is for debugging dynamically generated accessibility elements, which we're going to get into a little bit later in the talk. For more complex views like UI Web View, VoiceOver is going to find web accessible elements automatically. And again, Web accessibility is that's a whole nother talk, and that's a big topic just into itself. But you can look that up at the Web Accessibility Initiative on w3.org, and they've got lots of good stuff in there. You can, with most existing web toolkits, just get accessibility for free. I know that Digit and jQuery Mobile both implement WAI standards. I'm sure that your favorite reputable web toolkit does something similar. For simple UITableViews, you do not want to change is accessibility element explicitly on UI labels. So again, is accessibility element marks a control as being a part of the accessibility hierarchy, and that means it's something that can be focused. All the accessibility elements are also leaves of the accessibility DOM. And what that means is that the user is no longer going to be able to navigate to your cell within the table. And most of the time when you want users to be able to navigate to the cell so they can select the cell. Like in mail, if you marked the subject line of an email as an accessibility label, then they'd never be able to touch the actual mail cell, and then they'd never actually be able to navigate into the mail. So that's bad. UITableView cell actually provides very nice, sensible defaults for this. It actually just builds the accessibility label out of all of the child UI labels that exist within the cell. So you can that's actually pretty nice and gives you most of the time what you actually want. But you can override this by overriding accessibility label on UITableView cell or by setting it directly if you want. Oops, sorry, wrong way. For simple UI collection views, cell navigation doesn't work out of the box. That's because, unlike UITableViews, UI collection views are a really complex beast, and it's not really clear what are there are supplemental views, but you never really know with a UI collection view whether something is decorative or whether something is really important content for the user. So you need to explicitly mark a UI collection view cell as being an accessibility element. And then that will provide, you want to do it at the cell level, not necessarily, not at the subview within the UI collection view cell level, because you'll have the same problem that you get with UITableView cells, where you won't be able to select the actual cell, and then your selection logic won't run. So now we're going to get into the cool stuff, which is with UI Accessibility Container, you can build dynamic UI accessibility elements, and this is useful for really complex custom controls. So if you have either a complex custom control or something that has a lot of, is a single very rich content control. If you had a map, for example, if we were going to build a control that showed the layout of the Strange Loop conference, you would want to have individual sections. You wouldn't want it to just be an image, but you'd want to have individual rectangles of the map reflect certain named areas. And that's what UI Accessibility Container is going to allow us to do. It's going to allow us to mark off certain regions of a view as having important accessibility elements. And then we use UI accessibility notifications to build these accessibility elements. And so that way, to notify the screen reading system that the layout of our UI accessibility DOM has changed. And so that way we can make sure that VoiceOver is updating the current state to the user, so that then they can go and re-navigate the page and make sure that everything, that they can gain new context, or they can have VoiceOver reread things top to bottom for them. So we're gonna post UI accessibility post notification can actually be used for a lot of different notifications that you can post. But for our purposes, for most custom controls, all we really need to do is post either layout change notification, which is for very small changes. This is for things like having a control appear or disappear on the screen. If you don't do this, then what ends up happening is when the user taps in the area, even though there's nothing on the screen, they're still going to see it as being there. So this is, again, one of the reasons why it's important to actually test this way with your users, or with VoiceOver for your users, and that way you can make sure that you're getting the same context that your accessibility using users will have. Then also you have UI accessibility screen change notification. This is for really big changes. If you did something that blew away the whole screen, if you changed the view controller, and usually these things are going to get fired automatically for you when the view controller is changed. But if you have some kind of if you have a fully drawn custom view for a game or something, and you just change the whole game board, then you want to fire off UI accessibility change, and that'll go through and rescan the entire DOM. So now we're going to get into a demo. This is just a very simple single control that I wrote that demonstrates all this functionality. So ordinarily, if you were going to implement something like this, the red and the orange kind of look exactly the same on that screen. That's unfortunate. So this is actually, we've actually got four different rectangles here: red, orange, yellow, green, and ordinarily, you could just implement those as 4 buttons, but just to illustrate this point further, this is actually just one UI view that's then dynamically drawn using drawRect, and then when you do a touch up inside, I'm actually tracking that with touches ended, so that then I can pop up a accessibility or a UI alert view to say where you touched. So then we'll just have a little video just to demonstrate this in action for a normally abled user. Oh, sorry. This is what it's going to look like with VoiceOver. So this is where I'm actually just navigate. You can kind of imagine what it's going to look like just without VoiceOver turned on. So this is with VoiceOver turned on. And what this is going to do then, let me turn the sound up a little bit as well, because you can't really hear it very well. It's going to speak the names of each quadrant. So you're going to hear top right, bottom right, top left, bottom left, etc.
Top right button. Bottom right button. Bottom left button. Top left button. HJB accessibility.
And real quick right there, you notice that I didn't tap directly on the element that was selected. That's because in VoiceOver, to perform a selection, you just have to double tap anywhere on the screen.
OK button. Top left button.
Now notice that I just rotated the device, but all of my, now when I navigate again, all of the different quadrants are going to be updated with appropriate rectangle boundaries, and so we're still going to get the appropriate controls.
Portrait. Top left button. Bottom left button. Bottom right button. Top right button.
And so then we'll just go ahead and jump into the code that we use to do this. So within my UI view, and you'll forgive me if I've got multiple slides, since if any of us are iPhone developers, Objective-C is a really, really verbose language, so you'll forgive me if I'm not so terse. Within my view, I have a single update accessibility elements method, and this is where I build out all the rectangles that reflect where within the view the actual accessibility elements are. So essentially, this is just very simple UIKit math right here. I'm taking the screen and I'm taking the bounds of my view and I'm dividing it in half, top and bottom, and then I divide the top and bottom halves again, left and right. This is the important part here, is I'm building out the accessibility frames. Now, when you build when you're declaring the accessibility frames for a UI accessibility element, you need to make sure that your elements are in screen coordinates. And that's just a requirement of UI accessibility element. So to do that, you use the convertRect method on your view, and you make sure to convert it to a view of nil. And so that will put your coordinates in screen coordinates. So now I've got the 4 rectangles that represent my individual frames. And so then I can go through and build out. I'm just going to show you how I build an individual accessibility element. It's pretty simple. I just new it up with my accessibility, with its parent accessibility container. That's how we build out the DOM. And then I simply declare its label, declare its frame, and whatever traits. So in this case, it's a button. That's how we get our button-like behavior. That's how we know it's selectable. And then I'm going to declare the other 3 in very similar ways. Then I'm just assigning it to my to an array that I'm tracking in my class. This is the last important step. I want to make sure that I actually have a window before I post my notification. You don't want to be posted. You're gonna negatively impact the user if you're constantly firing off spurious layout change notifications. If you don't have a window yet, that means that you're not actually part of the UI kit hierarchy, which means that you're not part of. You can't possibly be part of the screen. So there's no reason to fire off your UI accessibility notification. So I just check for that. And then finally, we have this is the actual important code. This is the code that we need to implement as part of it, as a member of, or as a subclass of UIView, to allow VoiceOver to pull our accessibility notification or accessibility element children. So first thing we do is we override this accessibility element to no. Again, as I mentioned before, UI accessibility element is the leaf of the accessibility DOM tree, and what that means is that none of the accessibility containers can themselves be accessibility elements. If your accessibility container is an accessibility element, then VoiceOver will not navigate any further down trying to find child accessibility elements. Then these two methods are really, or these next three are really pretty simple. You just basically delegate them out to your containing array. So I've got an accessibility element count, obviously the element at index. This is a little bit different. We don't delegate it directly to the array because the contract says that if a accessibility element is requested out of bounds, you need to return nil and not blow up. And NSArray will throw an exception and crash your app if you request one out of bounds. And index of accessibility element, this is just, it's okay to return and it's not found if you don't have one. Finally, then we've got some more advanced, sort of medium advanced accessibility APIs. So these are for if you're building a accessibility element, increment and decrement. These are methods that you override directly on your UI view, and these are for things like if you have a slider or anything that is adjustable, you can support direct adjustability. That's because some hardware actually has direct buttons on it, and that's going to interact with Bluetooth with iOS, and it'll allow users to directly adjust things up and down. So this just gives direct access to that. Similarly, for accessibility scroll, this is for custom scroll views, and I actually haven't implemented a custom scroll view with UI accessibility yet, but it's actually a pretty complex piece to deal with. As I mentioned, there are other UI accessibility notifications you can post. A bunch of those have to do with scrolling and making sure that your user's position is up to date and consistent. Two more that are actually pretty neat are perform escape and perform magic tap. Now these also have to do with somewhat with specialized hardware. For perform escape, this is for dialogue. So this allows, if you have a non-alert view dialogue, if you're making a completely native dialogue, you can use accessibility perform escape to dismiss that dialogue. And again, sometimes there's specialized hardware for that, but there's also specialized gestures within VoiceOver just to say dismiss whatever modal exists. Perform magic tap is for invoking sort of the gestalt of your app. So like if you're a music app, the perform magic tap would play and pause music. And so again, this is for specialized hardware that has, some people can only interact with computer using just a single button. And so this is with that button press, that's what usually gets invoked in your app, is this perform magic tap. If you don't implement these, by default, they just return no, and that reflects the success of the actual thing. So if you don't have a single purpose of your app, if it's a big enterprise app, then perform magic tap obviously isn't going to do anything, and that's okay. And finally, UI accessibility focus is a way for you to track where the user actually is within the app. So while they're navigating with UI with VoiceOver. So as you saw in the video, you might have seen a little rectangle around the individual elements that I was scrolling over. So I can subscribe to these accessibility callbacks and get updated, and then update my screen dynamically in response to where the user actually is. So I can provide a custom UI. If somebody is doesn't have really strong sight, you could provide some affordances for them. And then new in iOS 7, this is actually something that's beyond just simple, is going to involve a larger audience than ordinary UI accessibility is content size categories. And so this is for just any people that just might not have perfect 20/20 vision, that want bigger text. In iOS 7, they've added the ability to define preferred text sizes. And so it's UI content size medium, large, extra large, extra, extra large, and extra, extra, extra large. And it's funny because they literally spell out extra, extra, extra large in the variable name. So that's accessible by settings, general text size. You get programmatic access to it on UI application. And the downside is that you basically, if you're using a custom font, you need to manage this almost entirely yourself. You have to provide your own mapping between what it means to be extra, extra, extra large and what actual font size that you're going to turn that into. And then you, of course, also need to make sure that your layout flows properly in response to that. If you're using auto layout and you're using UI font, preferred font for text style, then it's going to you're going to get it somewhat automatically. But that UI, the font that you get from there is system dependent. Right now, I believe it's Helvetica New Light. And so now we're going to do a seamless transition over to Android. The Android accessibility is under the Android.accessibility package. And basically for that, you really only need to implement, for simple accessibility on Android, just implement content description. And this is really not that hard. This is basically just like the accessibility label on iOS. On Android, all of the many controls that are focusable and that are user interactable, like text fields, buttons, they get some kind of content description based on their text. But if you have image buttons, and this is something as an Android user, and when I was trying to play around with this and find a guinea pig for building a third-party accessibility service, I discovered that a lot of apps are just really bad at this and they don't add content descriptions onto their pictorial buttons. So Twitter, for example, on your profile page, the settings button doesn't have a description on it. So when you click it, the Android TalkBack just says button to you, and that's it. And there's three of them. There's the settings, there's switch profile, and you have no idea what it is that you're doing if you can't see the screen. So this is available in Android.view set content description if you want to do it programmatically, or you can just use the Android content description attribute in your layouts. Then also you have focus navigation, so you should test this with the D-pad in the simulator. If your element is important, this is basically just like is accessibility element in iOS. Just set the item to be focusable. Again, if it is a user interactable element, then by default it is focusable. But for things like images, stuff that's really important to the user, you want to make it focusable. And again, you can just call that with view.setFocusable. Oop, come on. There we go. If you have a complex view navigation, if you've got a really complex business form, if you're the IRS and you've got a W-4, then you want to implement some kind of complex. You may have a view hierarchy that is different from the way that you defined it in your layout. So by default, Android is going to infer from the way you declared your layout the proper way to navigate your app. And if you've got something defined with a weird layout, then it may not navigate in a natural way. So what you should do is explicitly define what view you should go to after performing one of the focus directions from your view. So it's not really that hard to do. You just got to go through and make the effort to do it. So as for testing, what you want to use is TalkBack and Explore by Touch on the device. So this is just going to give you a realistic view of what the user is going to go through. On iOS, you actually have a really neat feature that it's called the screen curtain, and essentially that blacks out the screen and forces you to interact with the app just like a user with visual impairment would. And iOS or on Android, unfortunately, something like that doesn't exist. But you can still, it's still better to do it on a device because that way, yeah, I suppose you could like you could put a mask on or something to do that yourself. But I found that gestures work a lot better on device than they do on simulator, and basically you're doing all your exploration with gestures. Explore by Touch isn't present by default in the emulator. However, you can install the APK yourself. It's really not that hard to do. And then it does work. It's a little jittery, but then again, the emulator is basically jittery all the time. So it's not really a whole lot new. You also need to make sure that TalkBack works with gestures, so scrolling or zooming. TalkBack uses a lot of gestures itself, and generally speaking, the TalkBack gestures are the same to perform scrolling and zooming, or scrolling are the same as regular gestures in that you're just using one finger, except with TalkBack you're using two fingers. It's not really that big of a deal. Now, zooming is a little bit more complicated, and you're probably not going to be able to replace the zooming feature with gestures, so you're going to need to add buttons or something else, and you can actually discover that TalkBack is running, and then you can present those selectively. Also, you need to make sure that your focusable controls are a minimum of 48 dp. That's a human interface guideline requirement for Android, and it just means that it's a lot more likely that a user's actually going to be able to discover your control. So now this is the really cool thing. This is what really got me excited with accessibility on Android, was accessibility services. So you can augment third-party applications. This really illustrates the difference between the iOS and Android philosophies. On iOS, they give you a really, really powerful screen reader, and VoiceOver can do a lot of amazing stuff, and it even interfaces with some hardware. But you can't extend it in any way. Like, you get options that you can declare with your accessibility elements, and you get actually your accessibility elements on iOS can be marked up and have a lot more different behavior than they can on Android. However, with Android, you can just toss the entire system out that they provide for you by default and write your own. It's pretty neat. So you get to you can walk the entire Android accessibility DOM by yourself, respond to user actions, and respond to notifications. And in fact, you can actually, responding to notifications is really easy, and you don't even have to walk the entire screen. You get the raw notification data because the notification is just a bundle, and then you can use that to forward it off to other devices. So that's actually how Pebble implements some of its functionality with its watch. That was the very first accessibility service that I wrote. Was at Jive, we have an Android app, and for my hack day, for a hack day project that we got to do, we do 4 of those a quarter, or sorry, we do 4 of those per year, once per quarter. I didn't want to have to add accessibility notifications into, or Pebble notifications into the app, because then that would require a whole new push to production and testing. So instead, I just augmented it with a completely separate third-party service that didn't require any any new push of our code, and testers never had to work with it. It's a completely separate APK that has exactly one user. So when you're building your third-party accessibility service, you need to, this is how you'll lay it out with your Android XML. It's basically mostly the boilerplate. The important things are that you need to declare bind accessibility service permission. You need to register for the accessibility service intent, and then you need to add this metadata call, which is going to declare this. This is basically the only way that you can configure yourself to read from the screen. You can actually, other things that you declare in this metadata file, you can programmatically alter, but screen reading you have to explicitly state in the XML file. And this is new with Ice Cream Sandwich. The ability to read from the screen. The basic content description stuff has been there since Donut, but the good stuff at third-party accessibility services, I believe, is API 14. So then in the accessibility service config XML, this is where you actually declare what your service does and how it interacts with the user. So we're going to go through at a high level what the different attributes are. The really important one here is can retrieve window content. This is the one that you have to declare in your accessibility file. It's required for DOM access. If you don't have this declared, then all of your DOM requests are going to come back as nil. Description, this is what the user is actually going to see when they see your service listed within the accessibility options on Android. Notification timeout is the amount of time between notification events. So like as a user is dragging around on the screen, you might get you could potentially get many notification events coming back about the different elements they've touched. So they recommend a timeout of 100, and that's what I used. Package names is a comma-separated list of all of the, actually we'll go ahead and get into that next slide. The settings activity is a activity that you can present on the settings screen, and that allows the users to, that's going to allow the users to configure your service in some way. I didn't need one for what I did. The package names are a comma-separated list of all the packages that your service augments. So you can use Android, the literal Android word, if you want to augment the system package. So I was trying to use that to augment my lock screen to programmatically unlock my lock screen when it turned on. But unfortunately, the Samsung TouchWiz lock screen is not accessible. The buttons are not declared as focusable, so it's really unfortunate. You can discover your system packages with this simple ADB shell, and that way then you can, you might not know what the package name of the app you want to use is. So in my case, I augmented the guidebook app, which is the app we're using here at Strangeloop. I didn't know what its package was called, so you can just list it out, and it's pretty obvious. It was like com.guidebook.android, I think. The accessibility event types, these are all the things you can respond to, so you don't have to, this is just basically like a filter, so if you only care about when the user focuses on something or when the user clicks on something, you can get that. In my case, I just went ahead and used the type all mask because I had a bunch of different ones that I wanted to use. And then the feedback type, I'm not sure that this is actually required to be accurate. I haven't really seen this actually used in any of the UI, but I just go ahead and declare that my service was an audible feedback. So that's what it provided. Then the accessibility flags, these are ways that you can get more advanced features out of the accessibility service. So you can, if you're a test runner, for example, you can declare that you want to report view IDs. What that does is gives you fully qualified names of all your view IDs. I'm not actually sure what request enhanced web accessibility does. I've looked for documentation on it and I couldn't really find a whole lot. Request touch exploration mode. This basically just says my accessibility service is only useful if you use Explore by Touch, and there's also some more advanced features that require this flag to be set. This is all in the documentation. When you're actually writing accessibility service, now we're getting into the real meat of the actual class. We have on service connected. This is the setup method. This gets called once when your service starts up. Similarly, on unbind, that gets called when your service shuts down. I use this to fire up the text-to-speech engine, which I use to speak the values that I hovered over. On accessibility event is a required method, and that gets called when your actual accessibility event is received. And then on interrupt gets called if your service is stopped in the middle of performing accessibility events because the user navigated away or something like that. You can also get on gesture and on key event. This will give you when you're subscribing to gestures. On key event is when if you want to build a shortcut service, you can actually intercept every key press before it goes through the system and consume them if you want. The handy methods and objects as part of this system. Accessibility event, obviously, that's the thing that you're getting when you get the on accessibility event. That has the source, which if you don't declare that you need window access, can be nil. The accessibility node info, that's the actual accessibility DOM element. So that's got all the information about is it clickable, is it focusable, what is the content description, what should I read back to the user, things like that. The accessibility service get root and active window, that gives you that's like document.getBody. That's the top level of the DOM of the accessibility DOM, and from there you can walk the entire tree and get everything you want. And again, that can be null as well. So you just need to make sure every time you get a accessibility node from the service, you need to make sure that it's not null, or you just throw null pointers. One other really neat thing is accessibility node info perform action. So this is where you can actually do things on behalf of the user. This is really cool. So basically, it's most of the user interaction that can be performed you can do programmatically. This isn't an extensive list. I left out like 4 things just in the interest of you being able to read the slide. So for the demo, I didn't use the Strangeloop guide because the Strangeloop guide wasn't available when I wrote this. So as you navigate through, this is the screen This is the screen without accessibility or without TalkBack turned on. This is the screen with TalkBack turned on. There is a yellow rectangle highlighted around the overall rating if you accessibility hover on the element. Unfortunately, when you hover on that, it is not declared as, it doesn't have a content description, it's not declared as a button, which it actually is. So you don't get any kind of useful feedback. When you actually tap it, then you get a my rating call out, and you can actually view what the overall rating is, and you can rate it. So, and again, if I hover on overall, then it actually will speak back to me exactly what was said. So this is the way it behaves by default. So see how you get the my rating call out, no big deal. Then we'll go to the next one. This is with Explore by Touch turned on. Whoops.
General info.
Notice we get the feedback that we touched something, but we didn't hear, it didn't tell us what that thing was.
Overall, 2.673 votes.
And that's the behavior I would expect when I hovered over
General
that
info.
I would get the actual feedback of what the rating was. So that's what I did with the accessibility service. Is when you tap that button, then it programmatically touches the button, brings up the call out, navigates through the DOM, finds that overall label, and then captures the overall label's value and uses the screen reader to read that back to the user.
General info. Overall, 2.673 votes. General info.
And basically, as far as strategies for actually writing something like this, you just have to sort of construct a parallel state machine, because all you're getting an event stream from the system. So you have to do sort of like SAX parsing strategies when you're dealing with XML. Is you've got to build up your own programmatic DOM that exists, and you've got to be ready for that to all go away at any time if the Windows contents drastically change, or if your system's interrupted. So it's just really an exercise in creating state machines, which you can go to many other talks and they'll give you really great advice on how to do that. Then I've also got a giant load of links here. If you're interested in the actual implementation of this stuff, it's on GitHub. You should be able to just download the accessibility project with Eclipse and run it on your device, and you can interact with it. One other one I want to call out specifically is Google's Eyes Free Code project. This has a lot of great source and a lot of great APKs you can install, and also Matt Gemmel's sort of magnum opus on accessibility for iPhone. This is a few thousand word essay, and really great, and he's a really great accessibility guy. I think I've got a little bit of time for questions, maybe. Anybody? Okay. Oh, yes.
So in terms of accessibility, I noticed that you got the users text. Keep in mind is when you localize applications in different languages, I'm just curious.
Yeah, okay, so the question was about accessibility localization. You actually there is an accessibility value for the accessibility language, and then it's up to you actually to programmatically they don't have, as far as I know, they don't have localized bundles, but you can programmatically define a label properly according to the language. Okay, I think we're done. Thank you.